Hey guys, this is a video for parent functions for Unit 2. Our essential question is, what are the parent functions and how can knowing them be useful? Alright, so in Algebra 1, we learned about 3 parent functions. There's actually, I believe, 7 parent functions, but you won't learn about the other 4 until you get to Algebra 2. So in Unit 2, we talk about the very first 3 parent functions that you guys will ever hear of. So before we can even go over what the 3 parent functions that we learn are, we first have to understand what even is a parent function. Now, a parent function is the most basic function. Okay, it is the most basic. So what I mean by that is that all the other functions come from this one parent function. It's kind of like a parent and then they have children, right? You can't have children if you don't have parents. So the parents make the children. And so you're going to start off with the most basic function. This is where all of the functions come from. So we have 3 functions we tackle in Unit 2 in Algebra 1. We have the linear parent function, we have the quadratic parent function, and we have the exponential parent function. Now, these 3 functions are very different from each other, so it is important that you're able to understand the differences, not just visually, but be able to identify their key features in a different way. So we're going to go ahead and start and talk about the linear parent function. So what I want to first point out about linear is there's a keyword in linear, and that keyword is line, okay? Now, when I think of a line, I think of something that's a straight line. So I'm going to go ahead and define this. A linear function is a first-degree polynomial. Okay. Now remember back in Unit 1 when we talked about degrees, the degree was the highest exponent you had in your polynomial. So if your highest exponent was a 7, it would be a 7th degree polynomial. If the highest degree was a 5, then it would be a 5th degree polynomial. So if I'm saying it's a first degree polynomial, then the highest exponent we're going to see in this function is a 1. It's going to be the biggest exponent. We're not going to have anything other than that. Another key feature of a linear function is that it is a straight line. Okay, so a linear function is a straight line. So you could see some linear functions in a few different ways. It could be a flat horizontal line like this. Whoops. Okay, it could be a flat horizontal line. Now, I put arrows on this because it's impossible for me to write a line that goes on forever and ever. So arrows indicate to me that, hey, this goes on forever and ever. I'm using arrows to tell you that without having to write it all out. Okay, you could also have straight lines that are vertical, straight up and down. You could also have lines that go from, they start low and they go up high, so a positive line. And you also could have negative lines that go down like this. So there's different types of linear functions that you could see, but in all cases, they're always a straight line. Moving on to quadratic functions. This is the second function that we tackle. This is a second degree polynomial. Okay? And when I say second degree polynomial, that means that the highest exponent I see in this function is a 2. I also want to point out the shape that this makes. This makes something that looks like a U shape. Now there is a name for this shape and we will talk about it when we get to the quadratic function, but there is a name for it, but it does look like a U when you graph it. So when we graph this function, you're going to see it 2 different ways. For today, you're just going to see it one way, but in the future, you will see it another way as well. So quadratic function looks like a U. So it either faces up like this, or it can face upside down like this. Okay, so there's 2 ways we can see a quadratic function in Unit 2 in Algebra 1. Now, notice how I put arrows on the ends of these lines because I'm indicating that that graph actually goes on forever and ever. And you'll see that when we get to the example later. Okay, the last function that we tackle is the exponential function. Now, this exponential function is different from the previous 2 because they're all different from each other. It's not a third degree polynomial if that's what you're guessing. It actually doesn't have really a specific degree because a variable is its exponent. So the variable for the exponent, whoops. Okay, and it's also a curved shaped. I'll go ahead and draw some pictures of what that might look like. So, I forgot to mention. For a quadratic function, you want to look at that U as that little key feature. It'll help you remember that it looks like a U. So quadratic function has a U shape. Okay. Now the key word in exponential function is, I gotta go back to blue, is exponent. Okay, that's the keyword for exponential. And the reason why that's the keyword is because your variable is actually in the exponent. Typically when we have an exponent, it's always a number, but in this case, it's actually a variable, and we'll see that when we move on. Now, you're gonna see this in two different ways. Your exponential function could look like this. Okay, so it's like a curved shape, so I sometimes say it's kind of like a J, or it could be backwards of that, like a reflection of that, and it could also look like this. So, ooh, man, my lines are a little shaky today. Okay, so you could have an exponential function looks like that. So those are some little sketches to help you kind of identify what those look like. So remember, linear keyword is a line. Quadratic functions are U-shaped. Think about that U in quadratic. So you want to make sure you remember that. And then the exponential function keyword in there is exponent, and your exponent there is going to be a variable. Okay, now the next two keywords and key vocabulary words that we have are words that you've already learned from middle school, x-intercept. Now an x-intercept is going to be where the function, crosses the x-axis. So I know it crosses the x-axis because it's the x-intercept. So I'm going to go ahead and draw a little sketch of a little graph here, a little y-axis and x-axis. And just a reminder, which one is our x-axis? Well, our x-axis is the one that goes horizontal. So it's wherever the function crosses the x-axis. Now there's another word for x-intercept, as you see here. It is also the word 0. And I know that's kind of weird because it's a number, but it's actually another word for x-intercept. Okay, so if the problem is asking you to find the 0, it's just asking you to find the x-intercept. So these two words mean the same thing. Just make sure you're aware that 0 also means x-intercept. You don't want to be stumped up by that. Okay, moving on to the next word that we have here is y-intercept. Now this is where, oops, someone's alarm is going off outside. All right, this is where the function crosses the y-axis. So just like an x-intercept, it would cross at the x-axis. A y-intercept would be located on the y-axis. Okay, so I'm going to go ahead and draw myself a little y and x-axis. This is also known as a Cartesian plane, what I'm writing here. Okay, I'm going to go highlight the y-axis. So y-intercepts would be located on the y-axis right there. All right, so moving on to our very last two keywords. Now these are brand new to us, and they're actually two of the words that we struggle with the most that I've noticed. So not just in Unit 2, but in future units as well. So domain and range. So I keep saying so, I'm so sorry. Okay. Domain is always associated with the variable x. Always. So anytime you see domain, you always need to bring your brain to it's x. It's talking about x. Okay? So if domain is x, then range has to be our y, correct? Because here we have x's and y's, right? On a graph, we have x coordinates and we have y coordinates. So we have those two variables to think about. So domain is actually all of our possible x values. So we would have to list all the possible x values that are on this graph or on our function, and we'll talk about that in a little bit. Now, it won't be as needed as much today, but the next 3 lessons will be more intense over domain and range. All right, so domain is all of your possible x values. So since that's associated with x, that makes sense. So range, since it's associated with y, that's going to be all of our possible y values. Okay, so those are all of our possible y values. Right, so these are our vocabulary words, which are super important. We need to be able to identify, be able to describe them in some ways, or define them for people, right? So it's important that you're able to get comfortable with these and be aware of their definitions. All right, so we're going to move on to a first parent function here. Now remember, a parent function is the most basic function. So for the 3 functions that we talk about today, we're looking at the most basic function there is for that specific one. So for the linear function, we're going to look at the parent function. So it's going to be pretty basic, nothing fancy. So you're going to see that when we identify some of our key attributes, they're going to be pretty normal. All right, so remember, the keyword in linear is line, right? So actually, I'm going to use purple, I think. Keyword in here is line, which means it's going to look like a straight line. If it doesn't look like a straight line, then we probably did something wrong, right? Okay, so what is the parent function for the linear? Well, that's going to be y equals x, all right? Now, when we want to graph something, we typically use a graphing calculator, but because you're pre-AP, I want you to be able to graph by hand, because you will need to know how to graph by hand when you go and move on to higher level math. So typically you're given the x values. So I'm going to go ahead and give you the x values, -2, -1, 0, 1, and 2. So why did I pick these 5 x values? Well, because they give you the best image of your graph, because it's right in the center. And because it's the parent function, you want to be right in the center because that's where all the action is happening anyways. So I'm ranging my x values from -2 to 2 here. Okay, now how do I get my y values? So, well, you always start off with your x values and then you get your y values from that. Okay, you're going to use this equation above here. You have y equals x. Well, if y equals x, then anything that x is, y is also the same thing, right? If x is 3, y is also going to be 3. If x is 5, y is going to be 5. So anything that x is, y is. So how would you solve this? Well, because this is the parent function, it's actually not too bad. But if I have y equals x, right? Let's go ahead and plug in some x values. Let's plug in -2 first. I have y equals -2. Anytime I plug in a number, I always use parentheses, okay? Always, just in case, because you never know. Well, I have -2, so it's just -2, right? There's nothing, there's a 1 outside the parentheses. If I distribute that in, I just have -2. So y equals -2. So nothing fancy there. Same thing here. If I have y equals x, which is my parent function, and I plug in a -1 for the x variable, well, I end up with just y equals -1. So as you may have noticed, anything that I plug in for x, I get the same thing out for y. Well, why is that? Well, because y equals x. Anything that x is, y is also going to be the same thing. So we're going to go ahead and make these purple real quick. So again, if I plug in 0 for x, I'm going to get 0 out for y. If I plug in 1 for x, I get 1 for y. 2 for x, I get 2 for y. Now, I could show you all the math for that, but I'm not going to because I've already shown you the first 2, and you guys should be able to do the rest on your own. Now, I need to be able to graph this. So we're going to graph this, and if you don't know how to graph, here's a little bit of a rundown. Coordinate ordered pairs are x, comma, y. You go in the x direction first and then the y direction. The x direction is left and right, the y direction is up and down. So anything that's negative, you would go in the negative direction. Anything that's positive, you go in the positive direction. So for -2, -2, our very first ordered pair here, I would go to the x direction first, so it would be left 2, and then the y direction, which would be down 2. So -2, comma, -2 would be located right there. Okay, moving on, we have -1, -1, so we're going to go left 1, down 1. We're going to go at 0, 0, 1, 1, and 2, 2. Positive 2, positive 2, right 2, up 2. Okay, now I'm going to go ahead, we plotted our points, so we're almost done with graphing this, right? I'm going to go ahead and hop into Desmos real quick to show you something. So I'm going to go ahead and type in y equals x. And then I'll go ahead and include the on-level video of this because I showed them how to graph this with Desmos. But I want you to look at something, right? This looks like a straight line. Right now, ours is just a bunch of points. So how can I get points from Desmos? Well, to get points from Desmos, you would actually use this table right here. So you can actually click on this little gear icon, and if you click on it, it'll give you the option to create a table. And when it creates that table, it actually uses the same x values I used, and then they give you the same y values. So you're going to get -2, -2, -1, -1, and so on. So you'll notice there's 5 points on this graph. Now let me ask you something. Are these the only 5 points on this line, or are there more points than just these 5? There's more. We just picked those 5 points, and those are the only 5 points they graph, but I can actually extend this table and watch what happens if I extend this. You'll notice as I keep adding on numbers, the points come more and more and more. Well, it's because there's an infinite amount of points on this line. So we picked 5 points particularly to graph because that's what I asked you to do, but there's actually more than just these 5 points. So you want to go ahead and draw a line to connect these points together to state that there's a bunch of points here, but I'm just not plotting all of them, I'm just plotting these 5. And why do I have arrows? Well, if I go into Desmos here and I zoom out as much as I can, you'll notice that line never ends. It keeps going on forever and ever. And if you do this and you end up with these giant numbers, you can actually hit the home button right here and it'll bring you back to the main center. Okay, but this never ends, so I want to make sure I put arrows. Now I'm going to tell you something because not everyone's told this, and I remember I wasn't ever told this, but a line is actually made up of an infinite amount of points. So there's actually points all on this line right here. They're all tied together, but there's 5 pretty points, 5 specific points that I pointed out to graph here, but there's more than just these 5 points. But there's numbers and points all between these lines right here, a bunch of them, infinite amount, all throughout this entire line. But again, we just picked those specific 5. So it's super important that we, are able to identify that. Okay, so we're going to go ahead and identify our x-intercept first. So remember, the x-intercept is located on the x-axis. So I'm going to go ahead and highlight my x-axis here. And then I want to think about, where does this graph cross the x-axis? Well, it crosses at the point at the origin. Now, the origin is known as the center of a graph, which is also known as 0, 0. Now, you must write this as a point, and here's why. If you tell me that it's located at 0, I'm not going to know where to go, because in order to locate a point, I need an x value and a y value. So you don't want to just say 0. You got to tell me 0, 0, telling me exactly where the point is, telling me where the x value and where the y value is. So please make sure you write them as ordered pairs. Okay, now next we're going to find the y-intercept. Now the y-intercept is located on your y-axis, and so you would look at your graph and think about, where does my purple graph here cross the y-axis? Well, it crosses the y-axis at the point 0, 0. Now again, this is the parent function. There's nothing fancy going on with this line. This line has nothing fancy really going on with it, so that's why it's just 0, 0. Again, it's the parent, it's the most basic. There's nothing fancy about these numbers. You're going to see a lot of zeros and lots of ones today. Okay, so now we're going to move on to the 2 that we struggle with a little bit, so I'm going to try to explain this in the best way I can for you. So domain. Domain is your x variable, right? It's your x values. Please make sure you're always associating domain with x. You never want to get it backwards. So that would mean we need to look at our x variables, or x values here. Well, when you're looking at domain, you're thinking x. So you should always think x-axis, okay? Now your x-axis goes left to right, okay? Your x-axis goes left to right. So then you want to look at the graph that you made, that purple line, and I want you to think, does this purple line go to the left infinitely? Will this purple line continue to go to the left infinitely? Yes, right? Because we put those arrows there, we're stating, hey, it's going to go on forever and ever. Well, same thing if I go to the right on the x-axis. It's going to go on forever and ever to the right. It's going to keep extending forever and ever. And also think about this. There's more than just these 5x values, right? We plotted 5x values, but there's way more than that on this line. We just didn't plot them. So you want to plot as many as you can, but usually I only ask you to do 5. But there's an infinite amount, both left and to the right. Okay, so remember, domain is x values. You're looking at your x-axis, which is left to right. Well, if it goes infinitely to the left as infinite numbers and infinite to the right as many numbers as possible, how do I say that in math? Well, to say that there's an infinite amount of numbers and it hits every single number, that is called all real numbers. Okay, now all real numbers can be a lot for students to write, so I do let them shorthand it by saying ARN. Now, ARN stands for all real numbers. Now, your STAR test won't call it that. They'll just say all real numbers. They probably won't put ARN, but if you want to shorthand it, you can. And then the mathematical symbol for all real numbers looks like this. It's an R with an extra line inside of it. So that would be the symbol for all real numbers. So what does all real numbers mean again? It means that for any possible number on the number line, it's going to go through it. Okay, because domain is associated with the x variable, so I want to look at the x-axis. The x-axis goes left to right. This purple line, this purple graph is going to hit every single number to its left and to its right. Every number that's possible. So, all real numbers. We're going to move on to range now, which is our y values. Well, range is going to be our y values, so we look at the y-axis. The y-axis goes up and down. So if it goes up and down, let's think about this. Will this graph go forever down? Will my purple line go down forever? Yes, it will hit every single number down. If I can make this y-axis as super long as possible, and eventually this red line will continue to go down with it. Same thing, if I go up, this line will continue to go up, right? It's going to continue to reach up, up, and up, and up. It's going to hit every single y value. And then it goes, and I can also ask you, are there more than just these 5 y values? Yes. and it's going to hit through all of them. Now remember, a line is actually made up of a bunch of points all together. So there's actually a ton of points on there. They're just not graphed. We just write a solid line instead of plotting a bajillion points. So your range is your y values. Your y values is your y-axis. On your y-axis, you go from bottom to top. You're looking at the bottom of the graph to the top of the graph. This graph will go forever down to the bottom and forever to the top. It will hit every single number that's possible in humankind. So how do we say every possible number? That would be all real numbers. Okay? Again, you can short that saying ARN, or you can use the mathematical symbol for all real numbers. Moving on, we have our quadratic function. So this is the second parent function that we cover in Algebra 1. So the linear function is what we just went over, and remember that we know that it's a linear function visually because it looks like a line. So with quadratic functions, we're able to recognize these because they look like a U shape. So go ahead and draw like a little U here, right? It looks like a U shape like this. And this U shape actually has a name. The name of this shape is actually called a parabola. And I know that's kind of a weird word. It's not really another word you really have to memorize or know, but it is the name of the shape. So instead of calling it U-shaped, you'd say it's shaped like a parabola. Okay, so the parent function for a quadratic is y equals x squared. Okay, now this is the parent function, the most basic of the quadratic functions. All right, so we got to actually create a table so that we can plot the graph. Now, I typically give you the x values, so these values here are given to you. -2 to +2. I'm giving these to you, they're given. Now, I need to be able to compute out the y values. So I kind of forgot to mention this, but your x value is your input, right? Your x value is your input, y is your output. So x is what you're putting in, y is what you're getting out. Because the x values are given to you, you need to be able to solve for the y values. So we're going to be able to solve for all of these. So we're going to do -2 first for x. So using this function here, I'm going to plug in -2 for x. So I'm going to have y equals, gosh, my pen isn't working, y equals, and I'm plugging in -2 for x. And anytime I plug in, I always use parentheses, as I don't want to make a mistake on accident. Well, what is -2 squared? Well, -2 squared in a calculator, if I put parentheses, should give me +4. Why should it give me +4? Because -2 squared means -2 times -2, which should be +4. So I'm inputting the x and I'm getting out a y. Okay? Now you're going to do the same thing with the next x value, which is -1. I'm going to plug in -1 inside for this x value here. So I have -1 squared. Well, -1 squared is going to give me +1. -1 times -1 is +1. So I'd have a 1 here for my y value. Moving on, do y equals 0 squared, because I'm plugging in a 0 for my x value now. Well, 0 squared is just going to give me 0. Okay? So I keep going, right? I'm going for all the x values that I'm given because I need to be able to find the y value that corresponds to it. So I'm going to do the next value, which is 1. It wants me to plug in a 1 for my x. So I'm going to do 1 squared. Well, 1 squared is going to give me +1. 1 times 1 is 1. And then lastly, I have y equals 2 squared. Well, 2 squared is going to give me +4. Now I want you to notice something about your y values. They're all positive. Why would they all be positive? Well, because anytime I square a number, it's going to give me a positive outcome, right? If I square a number, I'm going to get a positive number when I take it out. So I'm going to go ahead and plot these 5 points on this graph over here to make sure we're able to plot these points, right? So again, every point is x comma y, right? So you always move in the x direction and then the y direction. So to plot -2, +4, I would go to the left 2 and then up 4. Okay? Then I would go left 1, +1, up 1. 0, 0 is at the origin. Then we have +1, which is right 1, up 1, and then right 2, up 4. Now remember, this is a U shape, so it's going to look like this right here. I mean, yours might not look perfect, but you want to try to go through all the dots as much as possible. And again, I'm stating that these lines go on forever and ever by putting those arrows there. Okay. And then I can actually plot this into Desmos just to show you that it does look like a U shape. So I have y, I'm going to go ahead and turn on projector mode. Y equals x squared, and it is a parabola. And notice, the more I scroll up on it, the higher that U shape gets. So it's going to go forever and ever. And remember, when you're getting bored or like you get distracted and you start zooming out a bunch, to get back to the main area, the center of the origin, you hit this little home button over here. So you hit the home button, it brings you right back to the center. Okay, now that we've plotted this, we're going to go ahead and identify the key features of it. So, x-intercept. Well, what's an x-intercept? An x-intercept is going to be on our x-axis, right? So we're looking for a point, or points, because you could have more than one x-intercept, of where this graph could cross the x-axis. Well, I see it crosses at the point 0, 0. And you want to make sure you put the point 0, 0. You don't want to just say 0, because how am I supposed to find 0 on a graph, right? Like if I gave you an empty graph like this, and I said, hey, find 5. You'd be like, I don't know how to find 5, because you only gave me one number, right? I need to give you two numbers in order for you to find a point, like 2, 5, or 5, -3. So you need an x and a y value in order to graph something. So when I ask you for the x-intercept, I'm asking you to give me the specific point of where it's located. So I need you to give me the x and the y value. Okay, now they're asking us for the 0. Remember on the very first page, what is a 0? A 0 is a x-intercept, right? It's the x-intercept. So they're basically asking, they're basically asking you for the x-intercept again, because a 0 is an x-intercept. Well, if they're asking you for the x-intercept again, it's still 0, 0. It still goes through the x-axis at 0, 0. All right, now moving on to the y-intercept. Okay, well, the y-intercept is going to be on our y-axis. Right, so I'm going to highlight my y-axis here. And I'm looking at all the points that cross on the y-axis. It only crosses the y-axis at one specific point, and that point is 0, 0. Again, this is the parent function for this type of shape, right? This quadratic here is the parent function. There's an infinite amount of quadratics that you could make, but this is the parent function. This is the start of all of it. This is the most basic one, which is why all of our key features are centered at 0, 0, because there's nothing special going on with them. All right, so that is our quadratic parent function. Moving on to our last parent function, which is the exponential parent function. Well, the exponential parent function, remember the key word here is exponent. Okay, the key word is exponent, meaning there's something special about my exponent, and it's the fact that it's a variable and not a number. So the parent function for an exponential is y equals 2 to the power of x. So instead of having a number for your exponent, you actually have a variable. So that's actually super important because it's different, completely different than what all of our other types of exponents look like, right? All right, now you're going to be able to calculate this in a table. Now you might have to use your calculator for this, which is fine. And again, I always give you the x values, so these x values will be given to you, so you don't have to worry about finding those. You'll be given the x values, you need to find the y values. Okay, so the first x value that I'm asked to plug in or input here is -2. So I'm going to use the parent function y equals 2 to the power of x and plug in -2 for x. So I have 2 to the -2. So my exponent, I'm plugging in a -2 because that's the first x value that I need to find. Well, what is 2 to the -2? Because you're like, I don't know what that is. Well, if you have a graphing calculator, you can just type 2 to the power of -2 in a graphing calculator. But because I have Desmos here, I'm going to go ahead and use Desmos. So this would be 2. And then to use an exponent in a calculator, it is this A to the B button right here. You just have to press it once, and it will bring it up. You'll see your little cursors up in the exponent, and you'll type in -2. And I get 0.25, which is correct. Okay, so we're going to put 0.25 here. Oops, it should be red. 0.25. So if I put this in a calculator, I get 0.25. When we move on to the next x value, the next x value is -1. So it's wanting me to plug in -1 for my x value. So again, I'm using this function and I'm plugging in -1 for x. So when I get 2 to the -1, 2 to the power of -1, I get 0.5. Okay, so 0.5 is what I get from that. Okay, let me continue on. The next x value we have is 0. So I'm going to plug in 0 for my x value here. 2 to the 0 equals, all right, well, if I have 2 to the 0 here, you're going to think it's 0, but it's actually not, okay? So I'll show you. I'll get rid of the -1. I'm going to type in a 0, and I get 1. Okay, 2 to the 0 is actually 1. Now, I can't really explain to you why it equals 1 yet because we haven't really gotten that far in the year. You'll learn in Unit 6 why. But 2 to the 0 equals 1. So when I plug in a 0 for x, for this function, I get 1. Moving on to the next x value, it wants me to plug in a 1 for the x value, 2 to the first. Now, this one's easy. What's 2 to the first? It should be 2, right? Because I have 2 one time. So 2 to the first gives me 2. All right, and then last, my very last y value, or x value here is 2 to the second power. I'm plugging in a 2 for the x value. Well, 2 to the second is positive 4. Oops, I forgot to write the 2 there. 2. There we go. All right, so as you can see, our numbers are slowly increasing. We start at 0.25 and then grows to 0.5, grows to 1, then to 2, then to 4. Actually, they're doubling if you didn't know. If you notice that pattern, they're actually doubling here. All right, so we're going to go ahead and plot all of our points here. So to plot the first point, negative 2, comma 0.25, we're going to go to the left 2 and then up just a quarter, right? So just 0.25, not a whole one yet. The next point is negative 1, comma 5, right? Negative 1, comma 0.5. So this would be to the left 1 and then up a half, because 0.5 is a half. Okay, so your left 1, up a half. So it's slowly rising. And then you have the point 0, 1. Well, 0 is your x value, which means you don't move left or right at all. And then you would go up 1 unit, okay? And then you're going to plot 1, 2, so it's going to be, you start at the origin as always, you go right 1, up 2, because 1, 2, and then you have right 2, up 4. Now you have this cute little curve over here, right? Now I'm going to go ahead and put this into Desmos just to show you something. So y equals 2 to the power of x, okay? And it's not enough just to draw a sketch of the graph. I need actual points on a graph for you to give me what I need, right? I need you to give me 5 points. Now, looking at this graph, it looks very similar to the one that we plotted, except ours has some points on it. But there's something about this graph that you don't really see yet because we haven't zoomed in. So down here, oh, I need my assistive touch, there it is. Down here, if you look at it, it looks like this crosses the x-axis, doesn't it? And I'm going to change this to like a different color, so it's hard to see when it's black because the graph is also black. We'll change it to green. All right, so it looks like this green line touches the x-axis, right? It looks like it touches it. Well, I'm going to zoom in, and I want you to notice something. I'm going to keep zooming in. It never touches. Look here. It never touches the x-axis, which is right here. So it gets super, super close infinitely, forever. It gets really, really close, but it never actually touches. So when I draw this curve, I want to draw it to where when I draw this line, it doesn't actually go through the x-axis, but it gets super close to it. Now, it will get close infinitely, so it never actually touches. There's actually an imaginary line there that it will never touch. We won't learn about it till Unit 8, so you just have to trust me for now. And then don't forget to include your arrows to state that in both directions, your graph is continuing both ways, right? Because if I were to zoom out on this, hit the home button. If I were to zoom out on this, it continues to go up and it continues to go to the right. So we want to make sure we are to the left. So we want to make sure that we state that the arrows are there, they exist, and they're continuing on. Okay. So we're going to move on to the x-intercept. Remember, x-intercepts are located on the x-axis. So, does this graph have any x-intercepts? The answer is no, because this blue function never touches the x-axis. So if it never touches the x-axis, does it have an x-intercept? No. So what I would want you to write here is none. If it doesn't have an x-intercept, you say none. It will never touch the x-axis, so it's impossible for it ever to cross the x-axis, so it can't have an x-intercept. Then it's asking us for the 0. Now remember, 0 is another word for x-intercept. So again, in this case, I still have none because, well, 1, x-intercept and 0 are the same, so if you get 2 different answers, then you probably went wrong somewhere, right? They should be the same with each other because they mean the same thing. So if you're asked to find the 0, it's none in this case, doesn't have any x-intercepts. All right, the next thing we're asked to find is the y-intercept. So I'm going to go ahead and highlight my y-axis, okay? Well, does this graph cross the y-axis anywhere? Yes, it crosses at the point 0, 1. Now let me ask you, is that different from the point 1, 0? It is very different because 1, 0 is actually located over here. You move 1 in the right direction and then 0 in the 1 in the x direction and 0 in the y direction. So 1, 0 and 0, 1 are 2 completely different things. So you want to make sure that when you write something down, that's exactly what you mean, because you don't want to write down the wrong point because then it's located in a completely different spot. All right, so those are your 3 parent functions. You have linear, which is a line. You have quadratic, which looks like a parabola, a U shape, and then exponential, which kind of looks like a curve. It's super important that you go through and make sure you double check and kind of go through domain and range again. Remember, domain is all of your possible x values. The reason why your domain for this line is infinite, all real numbers, is because it's impossible for you to list every single x value. So in math, to say that it's every value, every number, we say all real numbers. Same thing with the range. Your range is all of your possible y values. Well, this graph will go to the bottom to the top infinitely. So if it goes infinitely, Is it possible for us to list every single y value that it will ever be? No, it's impossible, right? So you would say all real numbers to state that it is infinite. So that is it for your notes. If you have any questions, please